Hello, my name is Colin Kavanaugh, and for my presentation I chose the state pattern design. And for the intent, the quote given from our list of options was, it allows an object to alter in between when its internal state changes. The object will appear to change its class. And I kind of interpreted that as this pattern organizes and keeps track of all the possible states of the specified object, so it is possible to switch to that state when needed as soon as possible. And if we keep going further, we get to the motivation, which it simplifies execution for objects that contain a large amount of different states. I'll get into more of that later on how that works. The changes are made in real time, so you don't have to wait for some background function to take place. Coding and concept are fairly easy to understand for simplification and management of code. And a couple scenarios when it is used would be when an object's behavior depends on the state, and these states need to switch at runtime. So more for the time aspect. And then also it is used when an object has multiple states. It simplifies the process of switching between these states. So if you have one object that has like a ridiculous amount, let's say 50 states, it's a lot easier to switch it using the state method than it is other methods. Here's my UML diagram for the state pattern. So you have the context, which defines the variables for which the state can be changed. And then that gets pointed to the actual state, which is the current state the object is in. And it pulls the concrete class, which is the list of all possible states the object could be in. So I have them numbered 1, 2, but it can go on and on and on. You can have as many as you like. Some consequences of it is, for example, let's take that 50 states again. That code's going to be pretty lengthy because then you have to code out each class of each state. But yeah, that just depends on the amount of states that are needed for your code. And then also for new objects, it is expensive for maintainability. And some known uses are anything that has different states and functions based off of those states. For example, be TV remotes, vending machines, and the example that I'm doing, a cell phone ringer. So let's say, for an example, sorry, my cat is meowing. An example of a state pattern would be the different state your phone is in while receiving and pushing a notification for a phone call. There are 2 states for the phone. You have your silent state, where the notification is not being pushed, and a ringing state, where it calls for a sensory output to alert the user. And so we go into the code for that. If you follow my cursor here, this is just some, your basic C++ stuff, setting up the functions, and then you have your class, each of your classes for each state that would be in. So you have your ringing and your silent state. This class here is what actually does the switchovers. And then you have your function here. So let's say these state contexts are running constantly on your phone all the time. Once it switches, it'll be able to send your notification. So this is the output that came up from my code. But of course, if you had this implemented on an actual phone, it wouldn't just print text. It would call for a function for it to start ringing your phone and then know when to stop. So yeah, that's about it that I have for my presentation. Pretty short and sweet. State pattern isn't that complicated to understand. It's just switching in between states when necessary in real time to help ease management and make it more simple for development. Thank you.